All right, Bellringer fans, friends, and frenemies, it's time for the Bellringer. And you know, we've been studying photosynthesis all week, and we're going to continue with our photosynthesis week. Today, I want you to know all about guard cells. Guard cells. Guard cells. All right, let's do today's Bellringer. All right. Hey now.
Mr. Kovacs class. It's Mr. Kovacs class.
You might learn a ton.
It's Mr. Kovacs class.
It's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
Did I read this right? Test Friday, December 1st, 2023. That's this Friday. This Friday. All of this good stuff we've learned over the last 4 weeks. Yeah. Especially a lot of stuff on the, a little bit of stuff on photosynthesis, a lot of stuff on transport through the membrane and the immune system. And of course, don't forget the diffusion through the membrane. State Lab, you know that's going to wind up on that. Let's talk photosynthesis, shall we? Yes. Can't do it without the chloroplast. Chloroplast, and of course, chloroplasts have in them lots of membrane, and embedded in the membrane is this molecule that's green and can hold on to water very well and capture light, which is called, that's right, it's called chlorophyll. Where's my chlorophyll molecule? There it is, chlorophyll. All right, chlorophyll is green because green light hits it and bounces off. Right, it reflects green light, so it looks green. Other lights, red, blue, you know, Roy G. Biv, they hit chlorophyll molecule and they get absorbed. Especially red and blue light, that's some high energy light that gets absorbed. And if chlorophyll has water bound to it, right, those red and blue light will break that water into bits. Now you know what the bits are, right? Good. Yeah, carbon dioxide. What am I, crazy? The bits are oxygen and hydrogen ions. We learned that there's two reactions, right? The blowing up of water is the light side of the force. And then on the dark side, there's where you take carbon dioxide and you take those hydrogen ions and you stick them on the carbon dioxides to make glucose, sugar. It's a dark reaction. So today's question is, well, two questions. Where does the water come from? And how do plants get that carbon dioxide? I mean, water is easy. Water comes up from the ground through their roots, right? That's how plants get water. But where does the carbon dioxide come from? That's right, it comes from the air. And to get into the leaf has to actually have little openings on its underside called stoma, or stomata is plural, right? Stomates, okay? Little openings on the other side of the leaf that allow air to come in and out of the leaf, okay? This way the cells that are doing photosynthesis can pick up carbon dioxide for the dark reaction. Okay? Now, the problem with having little holes on the underside of your leaves is if you're sitting out in the sun all day and you're cooking, water that you just brought up from the ground through your veins and your xylem of your veins would come, and then since it's been cooking, it would evaporate right out. Right? So when you're sitting there cooking during the day, you got to close those stomates. So during the light reaction, you have to use water that you got like the night before and blow that water apart. But if you try to collect water and blow it apart during the day, most of that water is just going to evaporate away. So you've got to close the gates of the stoma, and those are called guard cells. Guard cells. Guard cells control the openings of the stoma. Okay? So most plants during the day, they keep their guard cells, keep that stoma closed. And then at night, they open them up to allow carbon dioxide in for the night reaction, right, for the dark reaction. And looking at the underside of the leaf, you can see lots of different stomates here, stomata, all over. Right, this is a microscope picture of the underside of a leaf. Right, so guard cells guard the stoma. Cross section, you can see here the little opening. This is stoma, and it's squishy in here. I mean, there's lots of space in there for air to circulate inside of the leaf, and the opening's called the stoma, and the two little cells on either side are the guard cells. Right, they're usually open at night to allow carbon dioxide in and oxygen out, right? And not worry about evaporating too much water. But during the day, they tend to slam shut so that the light part of photosynthesis can happen without evaporating too much water outside of the leaf. We got light reaction, we got dark reaction, we got guard cells, we got stoma, chloroplasts, chlorophyll. Lots of good vocabulary going with photosynthesis. Thylakoid, stroma. Wait, we got stoma and stroma? They sound a lot alike. That's crazy. Boy, it gets more complicated as we go. So, yeah. We'll talk a little bit more about photosynthesis in class, but then also you have your first book talk for The Hot Zone, the book that we've been reading this quarter, or we just started reading. All right, so let's do that.